Hey, I'm going to find some absolute maximums and minimums. I guess maximums, if you really speak Latin, you're supposed to say maxima as the plural of that. So that's what that's about. Sometimes I just say maximums, though, because I don't really speak Latin very well. All right, so find the absolute maximum and minimum values of f on the closed interval and state what those values, where those values occur. So we're looking for the where and the what, right? The x value and the y value. So just have to do our usual thing and remember to check endpoints. And I'll show you here. I think I didn't do it in the notes. Show you here exactly how I want you to set up your sort of answer explanation. So first thing we're going to do, just regular old analysis for finding maximums and minimums. So that's going to be 0 at x equals 3/2. Okay, so this is what I want you to do. I want you to set up a little table that has x values and f of x values, and I want you to put your left bound, your right bound, and then anything that you find in between. Now, if you find something that's not in this interval, then you don't have to check it because we're only looking for things in this interval. So it's possible you could have a situation where you only have to check the endpoints. There's no zeros of the derivative in between. All right, so now what are we doing? What does it mean to check? It means to plug these x values back into the original function. So that's 2 and 3/2. Okay, well, I guess I'm going to do this without a calculator. So let's see, that's 9/4 times 4 is 9 minus 12, 6 minus 18 plus 10. I think I handled that okay. Looks like that's 1. And then plugging in 2. I got 4 times 4 is 16, minus 24 is -8, plus 10 is 2. So there you go. It looks like I have a minimum at f of 1, sorry, f of 3/2 equals 1. So this is the way of reporting it where you have the x value and the y value. I think it's the safest way to do it. Maximum at f of 1, which is the same as f of 2, which is 2. I guess I should feel pretty good about that, I'm not going to lie. But I guess I should just check the answer real quick to make sure I'm not spreading mis- or disinformation. It's an important but subtle difference there. The difference between disinformation and misinformation. I'm not sure I totally grasp it myself, but I'm working on it. 5/4. 5/4. Oops, I just looked at the wrong thing here. 5/4. 5/4. Yep, we're good. All right, let's stick a bookmark in there and move on to number 9. So I got x minus 3 all cubed. Sorry, x minus 2 cubed. So the derivative there would be 3 times x minus 2 squared, and that's going to be equal to 0 at x equals 2. And so what's my interval here? 1 to 4. Okay, so my x's and my f of x's. And I've got my 1, my 2, and my 4. There's my endpoints of my interval, and then my interior point. So plugging 1 into this, -1 cubed is -1. Plugging 2 into this, it's 0. And then plugging 4 into this, I get 8. So it turned out this is neither a maximum nor a minimum of the absolute variety. In fact, if you think about what this looks like, this is the cubic function shifted over 2. So that's a spot where, that's like a neither spot, where our cubic function comes in here, has a slope of 0 just for an instant, and then it changes its mind and goes back up. So there's my 1, -1, and 4, 8 up there. All right, so what do we got? I got a minimum at f of 1 equals -1. That's the where, and that's the what. And a maximum at f of 4, which is 8. All right, number 11. Got f of x is equal to 3x. Let's see, how do we want to do this? Do we want to do this? I guess I'm just going to do the quotient rule with this. You could move this denominator up as that thing to the 1/2. But I think the low, and I think I'm going to stick with this. So let's see, I got low, d high, minus high, d low. The d low of this is this thing to the -1/2, or 1/2 that thing to the -1/2. I'm going to put the 1/2 there, and then the -1/2, I'm going to put that on the bottom here, like that, times the derivative of what's inside. Alright, so I think that's going to look like that. And all over low, that's that thing. Like that. Now, if I want that to be equal to 0, then that is only going to happen when the top is equal to 0. So the top is going to be equal to 0. I'm just going to cut short one little algebra step here. If I have this minus this equals 0, well, that happens when those two things are equal to each other. So 3 times the square root of 4x squared plus 1 would have to be equal to 3x times 4x, that's that, over that, and then I'm going to cross multiply. Actually, I'm going to cancel out the 3's first, and then I'm going to cross multiply. So I get 4x squared plus 1 is equal to 4x squared. Well, that doesn't seem very likely, does it? Because then you could cancel that out with that, and 1 equals 0. Not very often is that true. So there are no places where this derivative, the derivative of this, is equal to 0. It doesn't have any critical points. So, and you might be thinking, but what about undefined, Mr. McGrath? Well, if there were any things that made the denominator of this equal to 0, then they wouldn't be in the domain. And anyway, 4x squared is 0 at a minimum, and then plus 1, so that's always positive at least. So, what does that mean? It means we only have to check the endpoints. So when I plug in negative, we should get the same value, right? Because this is, oh no, just kidding. I was going to say it's an even function, but it's not. It's just looking at the denominator. So here, when we plug in 1, I get 3 over the square root of 5. And when I plug in -1, I get negative 3 over the square root of 5. So this is a minimum at f of -1 is equal to -3 over root 5, and a maximum at f of 1 is equal to 3 over the square root of 5. If you're thinking to yourself, Mr. McGrath, you should rationalize these denominators. You know, that's for babies. And you guys aren't babies anymore. I'm very confident that in a pinch, if you needed to do that, you could. But that's like a relic of the olden days before calculators, when people were using slide rules. It's just not important to us. We got bigger fish to fry. All right, let's move on. So number 13, what do we have? We have f of x is equal to x minus 2 sine x on the interval negative pi over 4 and pi over 2. So doing our regular old analysis here, 1 minus 2 cosine x. So setting that equal to 0, that's going to happen when cosine x is equal to 1/2. Let's see, where is the cosine of x equal to 1/2? That's going to happen when the x-coordinate, you can just think about this in your head, right, when the x-coordinate is 1/2. So that happens here, here. That's like pi over 3, negative pi over 3. Negative pi over 3 is not actually in this interval anymore, right? This is the interval from here, negative pi over 4 to pi over 2. So we're looking for angles in there. That's the only one, pi over 3. So there's the things I need to check. So let's do it. Let's see. So here, I guess when I plug in negative pi over 4, I get negative pi over 4 minus 2 times the sine of pi over 4. So minus the sine of negative pi over 4 is negative square root of 2 over 2 times negative 2. I do believe it is that. Now that's a little bit tricky to figure without a calculator, like what is this exactly? Well, that's about negative, this is about 1/2, just rough approximation, and that's about 3/4, so this is about 3/4. It's about 1/2 minus 1/4-ish. That might be a good enough approximation for us to figure out what's up here. So how about pi over 3? So for pi over 3, oh, did I just do, oh yeah, we're good, sorry, need to bump you there. Pi over 3, that's 1-ish, minus 2 times the sine of pi over 3. The sine of pi over 3 is the square root of 3 over 2. So that's what I have there. The square root of 3 is about like 1.7. So that's 1 minus, so that's about negative 0.7-ish. And then pi over 2, the sine of pi over 2 is 1. That's about 3/2. So that's also some negative. Oh, that's kind of close. Jeez. Jeez. That's tricky. Because that is about 1.5, and that's about, oh, I guess that's about minus 1/2. So I guess that's the minimum there. So that's my best approximation that I can do without a calculator, I think. So according to that, if I am correct, we have a max, absolute maximum at f of negative pi over 4, and that is, the maximum value is that, and then my absolute minimum is at f of pi over 3, and that's going to be pi over 3 minus the square root of 3. Quick check in the back. Square root of 2, that looks good. Nailed it. All right, 15. Ooh, absolute value signs. Bummer. Well, that just means we're going to have to think. Okay, so how do we build up? So remember that we don't have any rules for taking derivatives of things with absolute value signs. They don't act just like parentheses because of the sign flipping or not. So our only recourse is to come up with a graph, and we're trying to go no calculator here. So where should I start? I guess if I knew what this looked like, that would be helpful. So that's a downward opening parabola shifted up 9. So I could start with that. So 9 and then minus x squared. And if you think about the roots of that, it's going to cross at 3 and negative 3. And then if I absolute value that, that's going to, sorry, that's bending the wrong way. It's going to flip up the negative arms of that. And then if I add 1 to that, it's going to shift the whole thing up. So the y-axis is going to be there now. So it looks like that. So where are the maximums and minimums? When I set this up, I definitely want to go from negative 5 to 1. And it looks like at negative 3, there's a minimum. And at 0, there's a maximum. And at 3, there's a minimum. And oops, that's outside my interval. So it looks like those are the values I need to check. Well, some of these are pretty easy because we just talked about them. That's negative 3, 1, 0, 10. Was it 9? Would I get shifted up 1? You just plug it in there, of course. And 1 and negative 5. Now I've got to check my endpoint. So when I plug in negative 5, 9 minus 25 is negative 16, but positive, so plus 1 is 17. It'd be hard to beat that, I think. And then when I plug in the 1, that's an 8. That's 9 there. So it looks like I got my minimum and my maximum. So I got max f of negative 5 is 17. My absolute minimum on this closed interval is at f of negative 3. It's at negative 3, and it is 1. And let's do a quick check of that. And then we will part ways for now. That's good.